whatever method you like. Typically, my students are like, just show me the calculator. I don't even care what you have to say about anything else. But all right, so I'm going to do it now with the calculator. The same exact problem that I just did. I'll get the same thing. I'll show you how from that I could backtrack and find the margin of error if I want. Anyway, I'm going to write it here. The calculator trick that you're looking for is 1 prop z int. Where is that found? Well, this is what it is, right? Where is that found? So if you don't have your calculator, you're going to want to pull it out, but here's my TI-84. TI-83 is the same. Now we're going here in stat. You're going to be in here a lot now. You do a lot of second bars and you do a lot of stat. Stat. I'm going over here to tests. See tests? Scroll over to tests. There's a lot of stuff in here. The first stuff we're going to use later. You see that it all ends in tests? We don't want a test. We want an interval. You have to scroll past that. You're going to see now interval and ints start popping up. Well, I want 1 prop z int. Well, how do I know? Well, I'm dealing with proportions. I'm dealing with z-scores. I want an interval. There's 1 sample. Kind of tells you how to do it. 1 prop z int. So again, how do I find that? Stat. Scroll to test. And go down past this stuff to these int stuff. We're doing intervals. And I want 1 prop z int for this. Because I have 1 sample. I'm dealing with a proportion. I have z-scores for proportions. And I want an interval. Enter. It directly asks you for everything, right? What is x? Well, let's go back to our problem. What was x? X was 856, right? 856. What was n? That's from our problem. We defined all this stuff. 1228. What was your C level? What was your confidence level? Well, they told us we wanted a 95% confidence level. So that, your C level that you put here is always the decimal version of your percentage. So 95% confidence level is 0.95. Down to calculate. Enter. Boom. 0.6714, 0.228. It gives it an interval notation. Interval notation from algebra. It means that this is an interval of numbers from here to here and in between, not including the ends, because in interval notation you have brackets if you're including the ends. But look at that. It actually calculates my p-value, 0.6971. It does that for me. And then it calculates my interval, 0.6714 to 0.7228. So it does it for me. Lucky me. So it went through the whole damn formula that I just did by hand, real quick, in one shot. Boom, there, it gives me my interval. Now, it gives me my interval in interval notation, right? So you have to obviously know how to interpret that, but you'll get used to it because obviously you guys are already about this calculator trick. 0.6714 to 0.7228, and then it's a matter of how you round and such. So this means that P is between 0.6714, 0.7228. You say the same thing. We are 95% confident that the true value for the proportion of blah blah is between 67.14% and 70. Say the same thing. Now, what if I ask you for E? Do you want to go through the calculator trick or do you want to go through the formula? If you go through the calculator trick, it gives you your interval. But it doesn't give you, your E, your margin of error. That you would have to calculate. How do you find E? You take the maximum number, you subtract the minimum number, and you divide by 2. So let's see what I get. 0.7228 minus 0.6714. Divided by 2. Let's see what I get. Excuse me. I'm sorry. Okay. 0.7728. So 0.7. Was it 7? No, 7228. 0.7228 minus 0.6714, whatever that value is, then divided by 2, 0.0257. That sounds familiar. It's exactly what I got using my formula. 0.0257. I should technically say approximately, right? Because everything is a rounding at this point in time. Okay? So I got the same numbers that I did using 0.0257. Same numbers that I did using the formula using my calculator trick, which is one prop z. Finding an interval for a proportion given one sample.